Welcome you all in the presentation of uh, subject irrigation engineering. Topic is regulating and cross drainage work. Part 1, canal regulation works. I am Trupti Pandya from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. So this is second video of part 1, canal regulating works. In previous video we have covered about the regulating structures like fall, escapes, cross regulator and head regulator. In this video we will continue with remaining regulating works such as silt excluding devices and other regulating works. Let's start with silt control devices. Scouring sluices or under sluices, silt pocket and silt excluders. These three components are employed for silt control at the headwork. Divide wall creates a silt pocket. So these structure names are already covered in my first video of divergent headworks. So divergent headwork structure include all these components, and the divergent headwork main component is weir wall and divide wall. So in detailed description about these structures are discussed in the video of divergent headworks, right? So in this, the divide wall is constructed perpendicular to the weir wall. So divide wall create a small pocket or a box like structure in front of main canal, and in that portion, means that pocket portion, that silt excluders are provided to control the entry of silt into the off-taking canal or main canal. Silt excluder consists of number under tunnels resting on the floor pocket. Top floor of the tunnel is at the level of sill of the head regulator. Various tunnels of different length are made. The tunnel near the head regulator is of same length of head regulator, and successive tunnels towards the divide walls are short. Velocity near the silt laden water is deposited downstream through tunnels and under sluices. It is more clear in the figure. We will see it later. Let's complete the theoretical portion. Silt excluder. The silt excluder is located on the upstream of divergent weir and in front of the head regulator that we have already discussed. The object is to remove silt that has entered in the silting basin through scouring sluices. Silt ejector. Silt ejector is located in the canal of takeoff from the divergent weir at 6 to 10 km in the canal reach. So it is away from the canal head regulator. It ejects the silt that has entered in the canal. So silt excluder is provided at the entry or at head regulator, in front of head regulator, where at the divergent headwork structure, while silt ejector is provided in the off-taking canal. 6 to 10 kilometer away from the head regulator, right? So this is a sketch of silt excluder. So tunnels are nothing but the again it is one concrete floor is there, and that floor is divided by number of walls, or we can say constructing the piers, right? So the section between the pier is known as tunnel, right? Which control the entry of silt into the off-taking canal. So silt ejector, this is different than silt excluder, right? So this is typical a tunnel design is there, and due to this tunnel section, the silt or the velocity get reduced and the silt is stopped at this location. So in this figure we can see that the water from the main canals flow through this section, approach channel, then the silt get deposited or trapped into these tunnels, right? So silt or sand or debris are trapped due to this construction of tunnels and piers and all that. Velocity of flow get decreased, and over that the relatively clear water get flow from further section of canal. Now that silt deposited over here get flushed out through the flow of water from this location, and it get disposed of from that canal location or silt ejector, right? So this is how the silt ejector works. So this, I think this model shows very good view of the tunnel section and pier section of silt ejector. Next canal regulation work is canal outlet or modules. A canal outlet or a module is a small structure built at the head of the watercourse so as to connect it with the minor or distributary channel. So it acts as a connecting link between the system manager and the farmers. So it is a one type of connecting structure, right? Non-modular modules. Non-modular modules are those through which the discharge depends upon the head difference between the distributary and the watercourse. Common examples of these type are open sluice and drawn pipe outlet. So now these small structures are to be constructed in distributary and other minor canals, right? It is a pipe-like structure, I can say. Next is semi-modules or flexible modules. Due to construction, a supercritical velocity is ensured in the throat and thereby allowing the formation of jump in the expanding flue. The formation of hydraulic jump makes the outlet discharge independent of the water level in the water course, thus making it a semi-module. Semi-modules or flexible modules are those through which the discharge is independent of the water level of the water course but depends only upon the water level of the distributary, so long as minimum working head is available. So semi module and flexible module are all works based on discharge. So this is one figure example, or examples are pipe outlet, open flume type, etc. Rigid modules or modular outlets. Rigid modules or modular outlets are those through which the discharge is constant and fixed within limits, irrespective of the fluctuations of water level of either the distributary or of the water course, or both. Rigid means that fixed amount of discharge, right, irrespective of the water level in the distributary or in the water course. The example is Gibbs module. This is Gibbs module's top view and cross section. It is nothing but the pipe outlet to divert or to supply water from the distributary to the outlet, from the small canal to another small canal, right? So this is the end of our second video of canal